In this lesson, we will discuss the concept of reservoir management. We'll also examine several techniques that can be used to increase the amount of oil recovered from a well. As a group, these techniques are called Enhanced Oil Recovery, or EOR. Ongoing reservoir management is an important activity for an operator. The overall goal is to maximize hydrocarbon recovery rates and realize as much economic value as possible. In previous lessons, we discussed that maximum production occurs in the primary recovery phase. Here, oil and gas is first produced with the reservoir's natural energy drive, and then artificial lift methods are used. Production decline and reservoir depletion also starts during the primary recovery phase. Depletion is caused by the drop in reservoir pressure resulting from the hydrocarbon production. The inevitable fact for every well is that production eventually declines, but there could be as much as 25 to 95% of the oil remaining in the reservoir at this point. Operators have numerous secondary and tertiary recovery techniques to extend the well's productive life. These techniques are often used in older wells to make them more productive, sometimes utilizing technologies that didn't exist when the well was at its initial production peak. But before an operator will carry out such activities, it has to consider whether they make economic sense. The precise definitions and categorization of EOR, secondary recovery, and tertiary recovery can vary and overlap in practice. We discuss EOR techniques using three categories: immiscible processes, miscible processes, and thermal processes. Let's start with the immiscible processes. The term miscible means able to be mixed. Two of the most common EOR techniques utilize water and natural gas, which are immiscible with oil, meaning they do not mix with the oil in the reservoir. Water flooding is the least expensive and most widely used enhanced recovery method. Huge quantities of water are introduced into the reservoir through injection wells. The water sweeps through the reservoir and moves some amount of the oil, which is lighter than water, toward the producing wells. Water flooding is similar to a reservoir with natural water drive. However, because water and oil do not mix, injected water will flow past some of the oil, leaving it behind. Immiscible gas injection uses gases that do not mix with oil, such as natural gas or nitrogen. Natural gas produced with oil, called associated gas, can be re-injected into the well to supplement the existing pressure of the formation, thereby forcing additional oil to the wellbore. Natural gas injection requires the use of compressors to raise the pressure of the gas to get it into the formation. Miscible processes use a gas or a chemical that can mix with the oil in the reservoir. The most common gas used today in miscible processes is carbon dioxide. When carbon dioxide is injected into the well, it mixes with the oil and vaporizes the hydrocarbons. This helps the oil flow freely through the reservoir. Because carbon dioxide is less dense than oil or water, it tends to rise towards the top of the reservoir and can bypass large quantities of oil. To help prevent this, carbon dioxide injections are often alternated with water injection to increase reservoir output. There are some obvious climate change benefits to carbon dioxide injection. In fact, pilot and demonstration projects are underway across the US to capture carbon dioxide in power plants and send it via pipeline to older fields to improve oil recovery. EOR chemicals used for injection are called surfactants. A surfactant is a special compound that causes oil and water to mix. Often, a second chemical, called a polymer, is injected behind the surfactant. The polymer increases the viscosity of water. This slows the speed of the water as it moves through the reservoir. Moving at slower speeds makes it less likely to bypass oil. Finally, Thermal processes involve the use of heat. One process is steam flooding. Steam is generated at the surface and injected into the reservoir through an injection well. The steam heats the oil, which reduces the oil's viscosity. The steam then cools slightly to form hot water, which helps move the thinned oil to the production well. Another thermal process is a steam soak, also known as a huff and puff. Hot steam is again generated, but this time it is injected into a producing well. The well is closed in to allow it to soak for several days. Again, the oil thins and hot water is formed. The well is then reopened and production resumes.